Red, blue, yellow, three primary colors that you learned in kindergarten. I am here to tell you, and by the way, who just loved their kindergarten teacher? Who was your kindergarten teacher? Who went to school, kindergarten here in St. Joe? A whole bunch of you. Who loved their kindergarten teacher? No, oh no. Who was your kindergarten teacher? They're usually such nice people. Who was yours, Bailey? Mrs. She looked like a Barbie doll? Yeah. There's two kindergarten teachers that both look like Barbie dolls. No. Did anybody here have Mrs. Weesmith? You had her in fifth grade. Yeah, she was, huh? That was Annie's favorite teacher, yeah. She dressed like a witch at Halloween, and her name was Witch Weesmith, and she was supposedly Mrs. Weesmith's, like, sister, like twin sister, who became a witch. They all believed it. That is so awesome about kindergartners. They all really thought that Mrs. Weesmith took the day off and Witch Weesmith came in on Halloween. It was awesome. All right. So, as much as you all loved your kindergarten teachers, listening to Ms. Nick now, listening to Witch Nick.
Where's Miss Nick?
Your kindergarten teachers didn't tell you the whole story. What you were learning was color subtraction. We're going to learn color addition. Addition of color, okay? The three primary colors in kindergarten are green, red, blue, yellow, and you can mix those colors together and get a lot of different combinations, correct? So if you put blue and yellow together, what do you get? Green. If you put red and yellow together, what do you get? Orange, that's right. And that's all about, listen baby, that's all about color subtraction. George's shirt looks blue today because? Correct. It's reflecting the color blue, which means white light hits it, it subtracts out or absorbs everything except for high frequency light. Blue is high frequency light. Okay? So it's reflecting the colors it does not absorb. That is a property of the molecular structure of the pigments in your clothes and everything around us that has different colors. So what? Why did they do that? You were kindergarten. It was on the MME, really?
Wait till it reflects the light right over.
Correct. Yep, and that's the color you see. It reflects the color you see. All right, stay with me. Stop yapping. So chatty for second hour. I know. Gotta get all caught up. Heard there was a big party this weekend.
There was?
Yes,
there was.
Heard that, yeah.
That was hard.
Yeah, heard there was some police intervention at said party.
Yeah, so awesome to try to join.
What?
So awesome to try to join.
You went to the party, Bruce?
Party.
Did you get arrested? All right. Oh, guess what I learned? Speaking of color, what did I learn this weekend? The color purple means?
Purple. The movie
with Oprah, right?
What does it mean, Jesus?
Okay.
Say it the politically correct way.
Girls are pink and boys are blue. At the Keystone Convention cannot make purple.
I don't get it. Yeah.
If you mix the two colors together, ergo, if you can go for your craft, and then make it purple. Pink is blue, red is red.
There you go. I think that's maybe the only sentence ever to have both ergo and frick the frack in it. Ergo. All right. So yes, indeed, if you use color subtraction and you put blue and pink together, you get purple. That is not the case for color addition. So the three primary colors for color addition are
No, confusing.
absorb light or the yellow light or whatever. Like if it's green, is that it reflects both yellow and? Yeah, that's exactly what it means.
All I know is why.
Everything you know to this point is a lie. Okay, here are the true primary colors. Red, blue,
Oh, no.
and green. Yeah, that blue circle is kind of ugly. Sorry about that. There we go. Okay, this makes me very unhappy. Isn't that better? A little lopsided. Not restarting. Okay. Color addition. Here we go. I'm just being quicker now. So, the difference here is that these are the three primary colors. If you, by the way, got really close to, not so much with the high-def TVs, but an older television or an older computer screen, and you got up real close and you could actually see the little tiny pixels of light that made the pictures, they were these three colors. And when you mix them all together, you get all the colors of the rainbow. Okay? This would be, instead of white light like we have coming from the lights in the room, although this light is sort of has an amber hue, but it would be like if I took 3 flashlights and covered the front of the flashlight with red, blue, or green cellophane. Okay? Red absorbs everything other than red. So the red light would get through. So those would be like filters. If I put a blue light over the front of the flashlight, or a blue filter over the front of the flashlight, what light would get through? Blue, blue. And what light gets here if I put green cellophane over a third flashlight? Green light, okay? So these are red frequencies, blue frequencies, green frequencies. Say it again, Acilia? Yeah, if I were to do this on a white board, you'd see a green spot where that was. Yes, that's correct. Go ahead.
But I'm confused. I thought the primary colors were red and yellow.
That is the primary colors in kindergarten. You're graduating now. So that was color, in kindergarten it was color subtraction. Now that we're in physics, it's color addition. These are what if you add these colors together. And by the way, in the spot where the blue and the green combine, there's a special name for that bluish-green color. Anybody know it? Cyan. There's my computer guy. Cyan is correct. The spot where the red and the blue, we don't call it purple, though. What do we call this one? Magenta is correct. How about red and green? Yellow, babies. Isn't that crazy? And what do you think you get in the middle where all three primary, where these come together? What? Yeah. And I'm going to demonstrate this for you. I am going to demonstrate this for you. So these three colors are called the primary colors. Red, blue, and green. Magenta, yellow, cyan are called secondary colors, and then white is what you get when you put all of them together. I know it seems backwards, but remember, we're adding frequencies. When you color with crayons, you're subtracting, you're absorbing out frequencies, okay? So, and if you think about this from a spectral orientation, right? Red green, and blue are the low, middle, and high-end frequencies. So we're capturing all the frequencies of white light, we're just adding them together. Usually, we end up with producing white light like we have in the room, correct? So you make the white light, and then what we see is a subtraction of those frequencies. It's a very different orientation. Now, what am I going to have you do on a test? I would ask you simple questions like, which ones are the primary colors?
So, will we have that diagram?
This is an excellent question. I'll give you a couple of options here. So primary are red, blue, green, RGB. Actually, it's red, green, blue usually. That's the way, the order. And the secondary colors, by the way, does anybody recognize the three secondary colors from anything? Secondary. I cannot write and talk at the same time. Secondary. Ink, for your inkjet printer, that is correct. Secondary, magenta, yellow, cyan. Okay? And then white, of course, if you put them all together. So questions on the test. What color of light do you get if you mix or you add red light and blue light? Magenta.
Oh, no, magenta.
Yellow.
What color do you get if you add red, green, and blue light? White. What do you get if you add cyan and red? White, correct. Because cyan is just green and blue, so green, blue, red, you get white. Yeah. What do you get if you add yellow and magenta?
Red. Red. Cyan.
Yellow and magenta?
Yellow and magenta.
Cyan. White.
Go with the white.
So what you're getting is green, red, blue, red. So it's all three primary colors, so that's white with a little extra red. Something like that's like a pinkish white. Yes, that's correct. I'm probably not going to ask you something because that's kind of a judgment call, right? What would happen if you put a red object under green light? So if I put this red pen under a green light, what color will it appear to be?
Yellow. Yellowish brown.
No, wait.
Oh, yellow.
Everything except for.
Yeah, I haven't heard the right answer yet.
Red.
So red is going to absorb everything, but
That's correct.
It's violet.
Because this is green light, so what does a red object do under green light? Absorb or reflect?
absorb.
Absorb.
So it's gonna be red.
Nope.
Green, you like white or black?
If you're wearing a piece of clothing wherein you absorb all the light, what color is it?
Black.
Black.
White.
That's black. Red object under green light looks black. Yes.
What is the ocean?
What is the ocean?
No,
Well, it's just a large body of water covering about 3. Why are you asking me that? Oh, what is addition? Color addition is transmitted light that mixes together.
So like what? Like.
Color subtraction is reflected light. So like a light shining on something. Yes.
That's addition.
Yes. Yes. All right, let's try another one. What if I take a blue object and I put it under a blue light? What color will it appear?
Blue.
White.
White.
How come George's shirt looks blue?
Because it reflects blue.
It reflects blue. What's it doing with everything else?
Absorb.
Yeah. So in order for this to look blue, what do I have to make it do?
Make it blue. Absorb everything else.
Absorb everything else and reflect
Blue.
blue. Is there blue light available to reflect here?
Yeah.
So what color is it?
Blue.
Blue. Is there blue light available here under white light?
Yeah.
Is it blue right now under white light?
Yeah.
Yes. So what color will this appear to be?
Orange.
What's going on?
Blue. Costa.
So is the reason why, like, black objects get hot outside because they absorb the most frequencies of
They're sucking in all the frequencies of light. That's exactly right. And a white, like a nice white tennis shirt in the summertime is cool because what does it do?
absorb the light?
Nope. White does what? Reflects all light. Right. Black lights are on the really high end of the spectrum. They're basically UV light. Now, they can't be pure UV because we don't see UV. So it just tends to reflect the highest of the high frequencies, and it makes like really light colors kind of appear to glow. I think. What color is what?
No, what color gets like reflected versus which one is absorbed?
Okay.
So like you said, when you shine a green light, red starts to kind of be black. So
Yep.
how do you know that
All right, we were heading there. I think this is gonna help. Ready? A blue object looks blue under white light because reflects blue and absorbs
Everything else.
everything else. A black object looks black under white light because absorbs all light. So if I take this blue object and put it under green light, will it absorb or reflect?
Absorb.
Absorb. All the light?
Yeah.
Is there any blue to reflect here?
No.
No. So if it absorbs all light, what color is that?
Black.
Black.
So it doesn't have like I don't know.
How about we practice with this, and then that might answer all questions that you all have. Can we try that?
Sure.
We try it, and then can you remember whatever question it is?
Yeah, no,
You two, right? Okay. Ready? So, anything to reflect here? All absorbing. How about here?
Yeah. Blue.
Blue. How about here?
No.
No. Black. How about here? White light.
Blue.
That's blue. Okay, you ready? I'm gonna make this really simple. Here we go. If blue light is available, it looks blue. So, blue.
Blue.
Black. Nothing, no blue available. If it is all absorbing, what color is that?
Black.
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 Yay.
Oh my
God.
White light is giving off all the light types,
Yes.
and red and black light would give off no color.
True black light, if
Yeah.
right, it wouldn't really be light. It would be the absence of light. Yeah. Tommy.
Now, what if we had like,
Yes, I am right.
A tough question. So, here's the deal. Tommy, I think you were asking, are we gonna have this available? Was that you that asked if we were gonna have this diagram available for the test? The answer is whatever you guys want. So if yes, you want it, I'm gonna ask higher level questions like,
Never mind.
so, up till now, no diagram. Up till, everything we've learned till now, no diagram. But if we take it to the next level, like the question that Tommy asked about purple. What if you have a purple object?
So on the test, it's gonna be, can we either memorize higher level?
No, I can't give you either or. We'll have to like make a decision.
Purple object?
So you can either have, if you have this available, I'm gonna ask you a harder question.
I think we should have it available. I don't think so.
See, you guys have learned. You know that I can just crank it right up. But let's talk about the higher level question, because then the easier ones will like seem super duper easy, right? So let's say I have a purple object. What's purple reflecting? Purple, which is now we're back to fricking and fracking again. So that's red and blue, right?
Yes.
So it's a mixture of red and blue being reflected, which to our eye looks purple. So, what color will a purple object appear under white light?
Purple.
Right. Under red light?
Red.
Red. Red.
Oh, I get it. That's cool.
What light is available? Red. What colors are in the purple pen? Red and blue. What'll the red light do with the blue part of the pen? Absorb. What'll the red light do with the red part of the pen? Reflect it. So a purple pen under red light will look red. How will a purple pen appear under green light? Black. How will a purple pen appear under yellow light?
Red.
You guys might want, first hour wasn't too thrilled about the higher level questions, but you're a little bit better. Where did you start your first hour?
I'm like second guessing myself.
Kind of get it?
My problem is all graphs. Which one is that?